And welcome to another exciting Algebra 2 video. In this video we're going to write the equation for our translation, and we're going to model this equation off of a story problem or a word problem where they give us a graph and kind of a scenario. So an assembly line machine stamps a company's logo on each product coming down the line. The graph models the stamp's height from the machine's axle Y at the time x seconds. So again, a machine goes up and down and does this kind of wave format function. It's drawing a wave. If I were to take a piece of paper and have that machine going up and down draw and the paper move as the machine draws, you'll get that wave function. At time x seconds since the machine turns on. What is the equation that models the motion? Interpret the graph's y-intercepts in terms of the content. Okay, so looking at this graph, I can see that either I have a sine function that is flipped across the x-axis, or I have a sine function that has been, that's hard to see, that has been moved with a phase shift over a distance. So I think what I will start out with here is I'm going to start out with my transformation equation. So I have y equals the amplitude. I think I'm going to go with sine. I mean, cosine, if it started at the top, came down and came back up, I would probably consider cosine, but sine again is the more typical trigonometric function to use in these cases, because cosine is just sine that is shifted by pi over 2. All right, so sine of b times x minus h plus k. So let's go through each one. Let's look at amplitude, my a. Well, if I'm looking at my amplitude, it looks like my peak here is at 1, my value is at 1. That's going to be, my amplitude is going to be 1. My midline is going to be my peak plus valley divided by 2. Peak plus valley divided by 2 is going to be 0, so k, my midline, is going to be 0. All right, it looks like I'm going to take this piece here and this piece here. And what this actually looks like is, it looks like it's 6 and a little bit. So I'm going to guess that little bit is going to be the 2 pi. 3.14, so that's 6.28, and that looks roughly about 6.28. So I'm going to say that my period is 2 pi, which makes b equal to 1, because we did not change our period, our cycle here. And then the last piece of this information, and this is just an assumption that it's 2 pi. I mean, it looks to be 2 pi. It could be just 6.28, but I'm just going to go with the 2 pi because I'm sure that they're trying to keep this as clean as possible for this example. But if it was some other number, you would just, again, take this value, 2 pi, divide it by p, and make this equal to 2 pi, which is this value right here, and then solve for b. So if it's another value, you'd use that to solve for b. All right. And then the last thing I need is my phase shift, h. And it looks like we moved over 1, 2, 3 units. So it's going to be 3. Now to write my function out, I'm going to say that this is y is equal to, I don't have to write the 1, it's already implied that the 1, sine of b is going to be 1, x minus 3. All right, and then we need to interpret what the graph's y-intercept means. What does this mean right here? What this actually means is that when x is equal to 0, the equipment is turned on. The equipment is near the midline of its cycle. So in other words, here's the robot arm, here's the part that we're graphing, here's the midline. It probably is sagging just a little bit, and it initializes going up and down. That's all it means. All right, guys, so this is writing an equation and a translation using a story problem. This is coming up with a function for our graph. We could actually test this out, plug it into a graphing device, and see if we get the same values, same models, things like that. And again, this is an interpretation that this is 2 pi because it does look like it's 6 plus a little bit more, but that does not necessarily mean it is. We're just going to go with 2 pi again to just make this a little bit cleaner, a little bit easier. All right, again, if you have any comments or questions, always feel free to ask, and I will catch you in the next video.